Hi everyone. In this video, I would like to give a small presentation on implement and demonstrate Q-learning algorithm. Let's know the contents covered in this video. Introduction, Q-learning overview, Q-table, basic Q-learning algorithm, off-policy learning, Q-learning example, convergence and optimality, applications of Q-learning. Introduction. Reinforcement learning is an interdisciplinary area of machine learning and optimal control concerned with how an intelligent agent ought to take actions in a dynamic environment in order to maximize the cumulative reward. The basic components are agent, environment, actions, and reward. A reinforcement learning model has four essential components: a policy, a reward, a value function, and an environment model. Q-learning overview. Explanation of Q-learning as a value-based reinforcement learning algorithm. Q-learning is a model-free, off-policy reinforcement learning that will find the best course of action given the current state of the agent. Uses of Q values to iteratively improve the behavior of the agent. Q-learning uses Q values to represent the expected cumulative reward of taking a particular action in a particular state. Q table. Building a table of Q of S, A values. The Q table is a lookup table where we can calculate the maximum expected future rewards for action at each state. Initialization and update of Q values based on the agent's experience. To learn each value of the Q table, we use the Q learning algorithm, which involves an iterative process of updating the values based on the agent's experience. Basic Q learning algorithm. Basic learning algorithm. Description of the key steps in the Q learning algorithm. Q learning is a model-free reinforcement learning algorithm to learn the value of an action in a particular state. It does not require a model of the environment and can handle problems with stochastic transitions and rewards without requiring adaptations. Exploration and exploitation phases. The Q-learning algorithm involves a balance between exploration, trying new actions, and exploitation, choosing actions based on current knowledge to find the optimal policy. Off-policy learning. Explanation of Q-learning as an off-policy algorithm. Q-learning takes an off-policy approach to reinforcement learning, aiming to determine the optimal action based on its current state. The agent's ability to learn Q values regardless of the policy being followed. Q learning allows the agent to learn Q values independently of the policy being followed, which contributes to its robustness and flexibility. Q learning example. Step by step illustration of the Q learning process is a simple environment. A Q-learning example can demonstrate how an agent learns to make decisions based on the Q values associated with different actions in various states. The example for Q-learning is a agent which learns to make decisions based on the Q values and with the help of different actions in various states. Initialization, action selection, and Q value updates. The Q learning process, which involves initialization of the Q table, selecting actions, and updating the Q values based on the rewards received. Convergence and optimality. Discussion on the convergence of Q learning. Q learning aims to converge to an optimal policy by iteratively updating Q values based on the agent's experience and the rewards received. The goal of maximizing the Q value to find the optimal action selection policy. The ultimate objective of Q learning is to maximize the Q value. For example, for each state action pair to determine the optimal action selection policy. Coming to the applications of Q learning. The first one is real world applications of Q learning such as game playing and robotic control. Q learning has been successfully applied to various real world problems including game playing and robotic control and optimization tasks. Success stories and challenges in applying Q-learning to complex problems. While Q-learning has shown success in many domains, it also presents challenges such as scalability to large state spaces and complex environments. Thank you.